everyone, this is Crystal from Leetcode. I have worked as a software engineer at Microsoft, Amazon, and TikTok, and today I am going to walk you through solving the valid anagram problems on Leetcode. This is a very common interview questions, and I will break it down step by step to show you how to approach it. Plus, I will share a few tips that can help you success in your coding interview. Let's jump right in. So the first step you have to do is understand the problems and then ask clarifying questions. Let's read through the problems. Given the two strings S and T, return true if T is an anagram of S and false otherwise. So before we start coding, let's make sure that we fully understand what has been asked. So what is anagram in this case? In here, it's really convenient as already have the answer for us here. So an anagram is a word or phrase formed by rearranging the letters of a different word or phrase, using all the original letters exactly once. You can have another questions for the interviewers, like what are the constraints? Is it like uppercase letters or lowercase letters? And in the interview settings, the interviewer actually expect you to ask some question about it. You can see the constraint in here. Let's say that S and T consists of lowercase English letter, so we don't have to worry about uppercase. We can also ask the interviewer that, what if the S and T is not the same length? We can see that if it's not the same length, then it cannot be the anagram since each letters will appear once. If the length of S and T's are different, then this could not be the anagram, so I think we can just return false. So I think now we kind of fully understand the problems, so we can move on to the next step here. So the next step in here is matching the problems with the data structures or common patterns. So in these problems is about comparing the frequencies of characters in two strings, which is a hint for using the data structure that can count or store this frequency. The first data structure that I can think about is using a hash map. So if we're using the hash map, we will have the key of it will be a character. And so for example, if we go through string S here, the character will be A. This will be 1 at first, so we go through it like 1 here. And then characters N, we also have 1. And A, we met A, so we update this one to be 2. And then G, we don't have it inside the map yet, so we will put G here. And then we note that we don't have R, the next character R here, so we don't have that, so we enter R to be 1 as well. Then we encounter A again, so we update A from 2 to 3. And then for M, we don't have it, so we put M here. If we go through T, we can actually do is we will minus all the frequency inside this map here. So first we have N, so N here, we have that in the map, so that means we will decrease this one to be 0. And then next one, we have A. So A in here, we minus 1 for it, so it's become 2. And then G, we become 0. And then another A, so this one will be 1. And then we have R, so we have 0. And then we have A again, so this one we will update it to be 0. And then we have N, it's the last one, so this one also be 0. By the end, you will have all of it be 0. So if all of it is 0, then we know that this is the anagrams. And if there is any other characters not inside this map, so it is not the anagrams. So we know that this data structure's hash map will work. There is another data structures that you can use to counting the frequencies just like map like this. We can do is array. So this one is like approach 1 here. And then in here we will have another approach is we will using array instead of map. You may think like, why is array? How I can store the character inside this? Let me explain this one. Since we only need to deal with lowercase English letters, so using a fixed size array of 26 elements for each character that we have is an efficient approach because this can avoid the overhead of the hash map. So for the hash map, you have the key like this, and value is actual frequency. For the array, what you would do is for each of this, So you will have an array of 26 character. You will have at first it will be 26 0. When you have 26 number 0 like this, so you will go through X character inside string S. So in here we encounter A. We will have this is the first index here. So this is a slot for A. And then 26 letters is A, B, C, T from the alphabet, A, B, C, D, E, F, G, and so on. So this one, the first index is for A, so we will update this one to be 1. So as in here, we have A already, so the next one is N. So N, we know that it should be somewhere down here. So for example, this one is for N, so we update from 0 to be 1. And then we have A again, so we update this one to be 2. And then G, so I just put this one to be G in here, so we update this one to be 1. And then for R, we know it's further down in here, so for example, this one is R, we will update this one to be 1. And then this one is A again, so we update this first index to be 3. And then M here, so we just update this one to be 1. So after we had all of this for S, we can do it for T as well. So T in here, so we also do the -1. So first of all, we have N. So we know that this is the index for N, so we will minus this one by 1, so it's 0. And then A, we update it to be 2. And then G in here, so this one would be 0. A again, so -1 for this, so this one only 1 left. And then we have R, so R is here in this index, we update it to be 0. A again, so we update the last one. And then N, so we only have this one left. But then you will have the array of on 0. So if it's on 0, then we know that this is an anagrams. And if it's have like 1 in some place inside this array, or -1 or any other number, then we know that this is not anagrams. So this is the second approach we will have here. We also have the third approach that we can do is we can sort this one. So for example, we have string S in here is like this, and then we sort it. So after we sort it, we will have it's like A, G, M, N, R, something like this. And then we also sort T as well. So T in here we will have is this string, and then when we sort it, this will be A, G, M, and R. So we can directly compare this sorted string, these two sorted string with each other. If it's equal to each other, then we know that this is anagrams, and if not, then this is not anagram. So we have these 3 approach. But which one is the one that we should write code for, and which ones the interviewer usually looking for? Once we have like multiple approach like this, we should consider the time and space complexities of all the solutions. So which ones have the lowest time complexity, then we will choosing that one. In this first approach here, we know that we are storing in the hash map, and we go through both string S and string T one time. If N is number of character in string S or string T, then it will be big O of N, since we only iterate it once. And then for approach 2, we also go through string S and string T one times, so it's also time complexities of big O of N. For approach 3, we know that we have to sort the character in string S and string T, and usually the sort algorithms inside Java or other language is usually big O of N log N. So this one is causing us more time complexities than other two. But in this one, you're only storing some value here. This one will have the space if big O of 1. And this one, you're also storing only 26 number inside an array. So with 26 only, then we know that it is big O of 1 as well. And for map, we know that it can be long, but it's only 26 character. So this one can be also considered as big O of 1 as well. So for now, we know that these 2 approach have the time complexities and space complexities the lowest. But you can see in here, This one will get rid of the head, like A or N or G in this hash map here. So this ones may cause us the lowest space complexities. So with that, I think we can go with this approach here. So after we plan out the solutions like this, then we can move on to the next part. We will coding this solution out. And in here, I am writing the solution in Java, but I also include the versions in Python or JavaScript in the description below, so make sure to check it out. Our first step is to check the length of S and T. If it's equal to each other, then we can continue, but if it's not, then we can return false right away. So S length, if it's not equal to T length here, then just return false. So that is one case that we're solving here. So the next one is we will create an array. So I will call it character count here. So once we have the array, we will assign it to be 26 number here. And then next, we know that we have to do a for loop to go through string S and string T. So let's write the for loop here. String I equal to 0. And then I smaller than s.length, and then I plus plus. We will update the character count. So at the current index, so s.char at here, if it's an A, then we will place this one in the first index. If it's a B, then it will put it to the second index. C, D, E, F is also like that. So with that, there's a minus trick in here. So in order to counting the correct index, we would do a minus A here. So if we can see from the example here, if S is at I, so if S at I is firstly is A here, so this character A minus with character A here, in Java, on character is number. So one is ASCII character set. As you can see in here, the character A actually in the code is 97. In character B is 98, and so on. As you can see in here until it's Z. Z is 122. So if it is Z, then it's minus the character A here. So actually you will have 122 minus 97, so it is 25. So we know that this is in the index 25. So this is a minor trick in here. So to find the correct index for it, we can assign here plus plus. For T, we will do it in here as well, so we don't need to have the separate for loop for it. Also using the same concept, char at I, and then minus A here. For T, we would do is minus minus. In string S, we will plus it, and then for T, we will minus it. So it's kind of like cancel out in the end. The last part in here is we can do a for loop through for the array. If on the number in the array here is 0, then we know that it is anagram. But if only one of it is not 0, then we know that it is not anagrams. So in here, we will check for it. So if count in char count here, if one of it, so count is not 0, then we know that we need to return false. After all of it, we check and it's still not false, then we know that it is anagram, so we can just return true by the end here. So here is all the code for these solutions. So the next step we need to do in here is testing the solutions. In the interview settings, some company doesn't have the IDE like this, that you can run the code on and test on the test case. Some of it just kind of like writings in the Google Doc, so you have to test it by hand. So what you can do in that situation is you can get the input and output and then walk through the approach like what I did in approach 2 here. We already have the IDE that we need, so we can just run it here. Minor mistake in here. Just rerun it. Okay, as you can see, both cases is accepted, so we can just submit it to make sure everything look good. So we have accepted solutions. So the last step in here, we have to do it analyze the time and space complexities. Remember, you have to do this for every exercise that you do or every coding interview, because this is expected to know about time complexities or space complexity. Like I said before, This approach have the time complexities if O big O of n, since we only go through it one time, with n is the number of characters inside S or T. And for space, we only using this char count here, and it's only 26 elements, so it is big O of 1. So this is a highly effective solution, both in terms of times and space complexities, makes it well suited for interview scenario. And that is how you're solving the valid anagram problems on Leetcode using an efficient frequency-based approach. Make sure you check out the Python and JavaScript versions in the descriptions if you're using those languages. And that is how you solve the valid anagram problems on Leetcode using the efficient frequency-based approach. So after every my exercise, I usually did is I will copy this part and then put it to my tracker. I'm using the Leetcode website here to track all my problems. So in here, I will paste in the title and then time start. I think I started like 30 minutes ago, so I just modify it here, and time stop here. So in here, we're using an array. You can just do string and array here. This part is a part that you can input your personal difficulty in here. This problem may be easy for you, but this also be difficult for others. So in here for me, I will choose 1. And then this part, you can put the tip for yourself. You can just do is, like me, I usually did is will copy all my approach and then put it inside here so I can just review it when time come to the interview. I just open this one to review. This is much easier than to go through all the problem again. And then that's it. You can add problems. And congrats, you're solving a problem today. So great work. So in here, the special things about this website is you can get your practice plan. You can see string and array that we just added. In this part, you will have practice now button. Once you click on the practice now buttons, it will show you the recommended problems that you should solve next. So in here, we have valid word abbreviations. It still have the difficulty is easy and frequency of it is pretty high. So you can view the problem here, or you already did this, then you can just do next problems, and then it will tell you which problem that you should do next. And then with that, you can just start working on it, and already everything is preview for you. You can just enter time start and time end and draw difficulty. And if you found this video helpful, be sure to check out more problems walkthrough on Leetcode, where I provide personal problems recommendations. Also, don't forget to like, subscribe, and click the bell button for more coding interview prep tips. Good luck with your coding interview, and remember, success is a sum of all small efforts repeated day in and day out.